being printed. And now n3 is equal to n1 plus n2, so it becomes now 3. Okay, n1 is equal to n2, now it becomes 2. If n1 modulus 2 equal to 0, 2 modulus 2 equal to 0, yes, that is true. Okay, then sum is equal to sum plus n1. Sum becomes 0 plus n1 is 2, 2, this becomes 2. Now n2 is equal to n3. What is our n2? n2 is equal to n3, this is assigned with 3 now. Yes, count is equal to count plus 1, your count becomes 3. Okay, now loop repeats. 3 less than 10, correct. Print that. Okay, yes. You are printing that. Okay, now n3 is equal to n1 plus n2. n1 plus n2, now it becomes 5. The latest value of n3 is 5, and n1 is equal to n2. Your n1 is assigned with n2, that is 3. Okay, and if n1 modulus 2, n1 is 3 modulus 2, which is not equal to 0, then n2 is equal to n3. n2 is equal to n3, it becomes now 5. Count is equal to count plus 1, it becomes now 4. Now loop repeats. 4 less than 10 is correct. Good. 4 less than 10 is correct. Now n1 is, yes, you are printing n1, so 3 gets printed, this series gets printed. n1 is equal to n2, this becomes now 5. Okay, this becomes now 5, and if n1 modulus 2, what is 5 modulus 2? It never equal to 0, so n2 is equal to n3, so it assigns with n2 is equal to n3. Your n3 is n1 plus n2. We have not calculated this. Okay, we have not calculated this. Alright, now n1 is equal to n2, which is equal to 5, and if n1 mod 5 modulus 2, now n2 is n3, so it becomes now 8. Fine, count becomes 5. Next loop repeats. 5 less than 10 is true. Okay, 5 less than 10 is true. Yes. Next, what happens? True. You are printing your n1, which is 5 gets printed. n3 is equal to n1 plus n2. n3 is equal to n1 plus n2. It becomes now 13. What you are doing? n1 is equal to n2. It becomes 8 now. Okay. If n1 modulus 2 equal to 0, what is your n1? 8 modulus 2 equal to 0. That is true. Okay. Then sum is equal to sum plus n. Sum plus n1. It becomes 2 plus 8 is equal to 10, like this. Okay. And n2 is equal to n3. n2 is assigned with n3, that is 13. Okay, count is equal to count plus 1, 6. It will go like this. Whenever it finds an even value term like 34 again, the 34 gets added to this sum. It goes on like this. It's very simple. Now you understood the tracing, right? Yeah. This is how you are supposed to be traced. Okay, when it encounters 13, 21, those are not divisible by 2. That thing we will not calculate the sum. When it encounters 34 is divisible with 2, then we are trying to calculate the sum again. Then the 34 gets added to this 10, now it becomes 44. Okay, so that is going to be there in your sum. We are trying to print that. Okay, you do that. This is very, very, very simple. Okay. Now this is another interesting program you are supposed to do. Okay, there are sometimes they will ask you for you do at your home. You do at your home for odd value terms. All odd value terms sum. You try to work on this Fibonacci sequence, or you can also have Fibonacci sequence prime number sum. prime number sum. Prime number sum. Yeah. We can discuss this in a number of ways. Okay. Yeah. So I'll stop here and nothing is there to do. I'll stop here and let us quickly revise what we discussed. So today, outline. Let us quickly revise what I discussed with you. Outline. What I discussed with you, I discussed with you the first very important program. What is that program? Yeah. Yes, prime number sum up to given number. Prime numbers sum up to given number. How we will develop? Should have two for loops. Okay, external for loop, internal for loop. Okay, this is for 2 to n your prime numbers movement, and this is and we'll also use this for sum calculation, and this interval loop is to check prime number or not. Okay, and we'll also use here break. The usage of break you will understand. And another program what we have seen is that this is very important. Okay, another program what we have also seen is that even valued Fibonacci series series even values sum. Fibonacci series even values sum, and we solved this using the while loop. Okay, we should have n1, n2, which is 0, 1 initially. We should also have n3. Okay, we should also have n3 definitely. I think third variable is also needed. So we solved this using while loop. Good. Okay. So we are always checking whether this n1 modulus division with 2 equal to 0. In case of to calculate even sum. In case of odd numbers, n1 modulus 2 not equal to 0. If this condition fails. Okay, we'll check this. Yeah, you think can we do this without having a third variable n3? Think of it. Is it without having third variable Fibonacci is possible? Question mark. Okay. Yeah. I'll stop here and thank you.